Hi, everyone. Thanks for being here. So, I'm Cassin Rosenblatt, a product marketing manager at the Sui Foundation, focused on the Sui network and its core tech. And I'm going to help moderate our discussion today, where we're going to dive into the Sui Data Stack and spotlight two new additions, gRPC and GraphQL. We're going to try and keep things balanced between the technical and the practical, so what these things mean in practice for devs, apps, and users. And after the demos and the presentations, we'll do some Q&A. Let me please introduce our guests. First, Brandon Williams is Tech Leads Manager on the Data Platform team, and Ashok Menon is a Senior Staff Software Engineer on the DevX team. They both have particular interest in improving developer access to blockchain data and have been key players in getting gRPC and GraphQL to its current stage. So after that, Brandon, the floor is yours.
All right. Ashok, you want to share your screen or the presentation?
Yes, let's do it. All right, whilst we wait for the slides to show up, excited to be here.
Yes. Oh, there we go. Perfect. So yeah, to sort of kick things off, we'll do a quick retro on kind of what the state of the art is on or rather the current status quo for how people access data on Sui. So the current old, right now the main way that people access data from Sui is using the JSON RPC API that is exposed from the full node. There's a couple of different challenges or issues with the existing implementation that we are trying to improve upon. Some of those kind of exist as there's kind of inconsistent retention of data. There's roughly 2 days of checkpoints and transactions that most full nodes keep. No object history is generally kept, and we end up having fully unpruned transaction and event indexes on full nodes, which leads to quite a lot of data bloat on full nodes. We have this centralized and very high latency, depending on where you are in the world, fallback to a archival service that the foundation maintains. And this is sort of to compensate for the fact that there's this inconsistent retention for how full nodes are configured today. The APIs, there's like no consistent and standard pagination for most of these APIs. There's some APIs that have pagination in them. There's other APIs that have no pagination, and so you're just kind of stuck with this like massive response payload. We don't really have a great subscription story today. We historically had this subscription API using
WebSockets.
WebSockets, thank you. But the way that there's nothing really wrong with WebSockets, but the semantics on how the subscription API was implemented lacked basic information to know like where you were in the stream, which led to when you had a connection break, you ended up having a lot of you had no idea whether or not you had lost data when you reestablished your subscription. And then indexing is very challenging. Every builder has basically needed to reinvent how they index data. Most folks we have found just scrape JSON RPC to get the data that they need. And the way that the JSON RPC API presents the data, you end up resulting in, I don't know, hundreds of API calls to get all the data you need for a single checkpoint, which is very inefficient and can lead to some non-performant indexing solutions. So that's kind of the current status quo and what we're attempting to improve upon.
Yeah, and now let's talk about where we're headed, or almost where we are now, and what you can try. So the new, starting with, of course, full nodes. So full nodes will still offer RPCs. They're going to be using gRPC, and this is still a good source for many clients, especially if you're caring about kind of tip of the chain requests, staying close to real time. So if you're building things like backend services as part of mining or exchange operations or market makers, the full node gRPC is a really good way to go. On top of that, we're offering an archival service, again, serving through gRPC. And this is where you go to say, get your object ID, by giving an object ID inversion, get the object contents or transaction by digest and so on and so on. So it's point lookups, but it's kind of unpruned historical data, which is obviously very useful if you want to show users your kind of transaction history or the transformation of that object over time. Then on top of this, we're building a general purpose kind of batteries included RPC using GraphQL. This is what you can use if you're building kind of tools and front ends, things where you want to have access to all these different services like the archival service, like the full node, and like rich historical filtering based queries all in one place. And we also factored out a indexing framework from the indexer that powers GraphQL, so that if you do have any needs that aren't met by this, what you can truly call it a stack now, you can still build an indexer yourself and serve a custom RPC from a database filled by that. So that's the kind of new stack at a very high level and what you could use all these various parts for. And I'll hand back over to Brandon to talk about gRPC in a bit more detail.
Yeah, you want to move to the next slide? So why did we kind of choose protobuf and gRPC as opposed to just like implementing a new JSON RPC API v2? There's a couple of reasons for this. One, protobuf is a very extendable binary format. This kind of leads to Sui is a high performance chain, and there are some clients who want to limit as much latency as possible. So having a very efficient binary format that they can consume kind of eliminates some extra overhead of needing to deal with JSON encoding. But protobuf does have a canonical human readable formats like JSON and protobuf text that you can use in various different toolings in the ecosystem. And there's great code gen support for most major languages, where so you can automatically kind of take the schema that we have and be ready to go in basically most modern languages. And then gRPC in the same vein, it's well supported in most languages today. You can code gen and get client support in various different languages, and it's very well built for having support for unary RPCs as well as streaming RPCs, which will suit us very well for when we are introducing robust subscription APIs. We've done a number of things semantically to the service to improve upon the existing one. So one, all of our APIs are going to be following kind of gRPC best practices and be idiomatic when it comes to how pagination is handled. We also have this concept of field masks that lets a client control what part of the response the server returns, so that if you're only interested in a very small slice of the data, you don't have to pay for the cost of downloading all of that. Given the way that we're restructuring how the indexes and that are kept on the full node, we're only going to keep the indexes that are necessary for the transactions that are actually stored locally on the full node. As we're removing the fallback mechanism, this will lead to more reliable and lower latency responses from full nodes. And this also leads us to having the ability to increase and expand the amount of retention that a full node can have, basically more efficiently using the storage that full node operators allocate to their nodes. And we ended up, as Ashok mentioned, we have this archival service that will offer a much larger retention window. We expect full nodes will probably be able to serve a month or so of data. And then if you need anything longer term than that, then you should be able to go to an archival service, which will offer the same slice of the gRPC API to do kind of point lookups on your transactions and objects and the like. And each service will end up advertising what their low and high watermark checkpoints are for data availability. So it's very clear when you're talking to a service what their available range is. Okay, and now I'm gonna try to share my screen here to move on to a demo. All right. So this is a live demo, so forgive me if I make some typing mistakes here. There's a bunch of different tooling in the gRPC ecosystem that you can use to interact with gRPC services. One that I find myself using quite a lot is buff. So you can use buff curl and list the services and the methods that a particular service supports. And so this is a full node running on mainnet. You can see all the various different services here. Given this, we can go ahead and call one of these. So we can go and call the service, gets service info, and we get some information about the full node that's running. We can get the binary version that it's on. We can get its low and high watermarks. We can get the timestamp for the latest checkpoint, and we can find that this, the chain ID that this node is on, and that it's on mainnet, as well as the current epoch. For epoch, we have a get epoch API. You can go and you can call and you get a bunch of different information about the epoch. You can also limit what kind of information you end up asking for. So if we just want the epoch and say the start and end time and the first checkpoint in the epoch and the...
You got a typo on epoch, right, Brandon?
Say that again?
You got a typo on epoch there.
Oh, man. Thank you.
No worries.
There we go. Would have yelled at me if I did that wrong. So this is the current epoch, and so there isn't a last checkpoint yet. So you can kind of see that, but we can go and we can edit this response, and we can go ahead and add which epoch we want, and we'll get the last epoch, which was 899, and we can see here we get a little bit more information, the start and end time, as well as the last checkpoint. You can see that the last checkpoint is just one off of the first checkpoint of the current epoch. Subscriptions are a thing that we have now. We will be adding more subscription APIs, but to start, we can, oh man. All my typos, it's just easier to. There we go. So for right now, we just have an API to subscribe to all the different checkpoints. And so you can get all of the checkpoints and their contents. You can see here the default is to just kind of not give you any of the data, but we can go ahead and specify to the service that we want a little bit more data from this checkpoint. So we can go ahead and we can say, hey, give us the digests of all of the transactions, as well as maybe the status of those transactions. So we can let a couple of these go through, and we can kind of see for each. Oh, let's see here. I had a typo. Probably still had a typo there, but so we can see for each of these transactions, you can get the status, and this, you can see this one had an error, and so a little bit of information about what that error was. We also have a simulate API, which is replaces the dry run API that we had before. I will open up and show you what simulate here is. So if we look at to avoid me having to type all this out, I prepared this ahead of time. So you can specify a transaction by in a JSON-like format. So this particular transaction is doing something quite simple, where we are just saying, hey, let's call get the current timestamp from the clock on chain. And we will go ahead and ask for just the status, the outputs from the simulate, and then maybe the transaction BCS for the fully formed transaction that the service will actually executed or simulated. And so if we look at here, we got the BCS, the transaction was successful, and the return value from the current timestamp is a U64. Which is this Unix timestamp rendered there. You can also do things with simulate, where if you want to go ahead and look at call private functions, or you want to go ahead and experiment a little bit more, you can go ahead and disable some certain transaction checks. And this will let you do a couple of other things, like you can provide an object in a BCS form and say, hey, use this version of this object instead of whatever's on chain. So give you a little bit more flexibility if you are kind of wanting to kind of explore and play with different APIs on chain. So in this particular instance, I just substituted the current clock on chain with the BCS serialized format of a clock object that just has the timestamps into 1, as you can see here. That probably about does it for sharing some of the things that you can do. There's a lot more, but that'll give you a little bit of a taste.
There's a pretty interesting question as well that came up during the demo. I don't know if Brandon, you want to cover that?
Yeah. Do you want me to read this question on here?
Yeah. Or to answer, I think everyone can see it, right?
Everyone can see it. Yeah. All right. So can a different service be used as storage beside Bigtable? So yes, this is possible. And exactly as this question highlights, is that right now we have an implementation backed by Bigtable. And the API for accessing that data, reading that data from Bigtable, is just an implementation of the gRPC service. And so all somebody would need to do if they wanted to have an archival solution based off of something other than Bigtable would be implement the reading and writing to whatever that storage layer is in terms of that storage. So basically a writer to populate that database and then implement the gRPC service that you can stick in front of it to read from it.
Absolutely. And one other thing that I wanted to call out that was very cool about Simulate, if you're used to using dry run or dev inspect, is the fact that you can now pass your transactions in as kind of JSON and not fully formed. This was something that, if you've used dry run or dev inspect in JSON RPC before, you have to provide a full transaction. So if there's an object input, you need to provide the full object ref for that input. And here in the demo that Brandon showed, you could just provide an object ID and the service figures it out for you. So this should be super helpful for working in ecosystems where you don't have a full transaction builder to hand. You can now just work in JSON, which is super cool. So over to GraphQL. firstly, to talk about a little bit why we even picked GraphQL and why did we factor out this indexing framework, all of this stuff. So GraphQL, what we found was its flexibility, the fact that you can write composable queries in it, made it a really good choice for an RPC that you could kind of go to for as a default for like most of your needs. It means that we can plug in these various data sources, and as a client, as someone querying the service, you could then go to one place, write a query, and it can pull from archival, it can pull from a Postgres database, it can send requests to the full node, and often multiple times to serve one request. And we'll see that in the demo in a bit. We also found that this ability to nest queries works really well with Sui's object model, where you have these distinct entities on chain that have relationships to each other, objects to objects, or addresses to objects, or transactions objects. And the query interface the GraphQL provides matches really well with that. And then the other major factor here is that there's so much great tooling for using GraphQL to write front ends, and we want to make that really easy and approachable for folks building on top of Sui to build a front end on top of your Move packages. So that's why GraphQL. And then the indexing framework, this kind of came about as a natural consequence of having to solve the hardest version of the indexing problem, where you have to index all of the chain state. You have to keep up with the chain. You have to be able to backfill quickly whilst capturing all the activity on chain. Once we had done that, firstly, we found that there were some common patterns that we had to solve in that case, but in custom indexes for different applications, you'd have to solve the same problems. And secondly, they were really hard problems to solve, so we didn't want everyone to have to solve them from scratch. So we packaged that all up. It's in a single library now, and you can now use that to write a completely custom indexer that deals with the details around where to fetch checkpoints, how to do retries, how to deal with parallelism, what to do for metrics, and you just have to worry about what data do you want to get out of a checkpoint and how do you write that out to a database. In fact, in the past, I've done a talk where I wrote a custom indexer live as a live demo within 10-15 minutes. So it's very, very approachable. We have docs on the Sui doc site for how to write one of these custom indexers. So very much recommend you take a look at that. So that's the kind of technological side. Let's have a look at, again, the semantic changes that we made, taking advantage of these things. So from the GraphQL perspective, we were able to, again, lean into using idiomatic APIs, things that fit the interface that we're using, in this case, GraphQL. So making good use of pagination and nested queries. We also were able to expose much more expressive filters that have longer retention, so 4 weeks or more retention for things like give me all of the transactions sent by this address or affected by this address, give me all the transactions that touched this object recently, all these kinds of things. And of course, we're able to pull in things like the archival service. So if you have a point query like give me the object by ID and version, you can send that to GraphQL as well, and it will kind of route it naturally to the archival service. And this includes if that request comes naturally as a consequence of some nested query. So, for example, give me all the inputs to this transaction, give me their contents, things like that. And another interesting property that we added as part of GraphQL is this notion of consistency, which is the fact that you can continue making requests as if they happened at one single snapshot in time at one specific checkpoint. And we'll see in a demo why that's interesting and useful. Then on the indexing side, to give you an idea of the kind of things you can take advantage of building on top of the framework, the system that we're currently using is able to give us end-to-end latency from something happening on the chain to you being able to write it of about 1 second. And that includes the actual activity on chain. We can run this indexer at 100 times real time to backfill, which is much faster than we were able to. And it means that you can backfill the whole history of the chain in between 2 days and 2 weeks, depending on how much work the pipeline is doing. And as I mentioned before, you can reuse all of this good stuff as a framework. So that is the GraphQL side and the framework side. Let's have a look at a demo to see GraphQL in action. So here I have a couple of queries I want to run you all through. So again, like Brandon mentioned, live demos. So bear with us as we make some typos and kind of fumble along. But the first thing I want to highlight with this demo is we have this interface. So this interface is actually a website that you can visit. It's graphql.mainnet.sui.io/graphql. There'll be a link at the end. And so that's already a major benefit. You can go here, you can try queries out before you write them in. You can access all the documentation here to see what APIs are available, what they do, what types do they return, all of this good stuff. And then, of course, you can actually run the queries. So here, I have a query that fetches a SuiNS name. This happens to be my SuiNS name, and gets all of the kiosk owner cap objects that I own. We'll just run that quickly. So you can see I have a kiosk owner cap. It's for this kiosk. So already you can see here this notion of kind of flexibility and composition. I'm able to make kind of multiple things that would take multiple 2 or 3 requests in JSON RPC. There, a single request here to go from a SuiNS name to the address, check if it's valid, get its objects, get their contents, filtering by type. So this is all already great. Then if you take, say, we want to look at this kiosk and see, what objects are in that kiosk, we can do that too. So with kiosks, the objects are added as dynamic object fields. So now we can run a query here that says, for this object, which is our kiosk from before, get me all of the dynamic fields, get me their names, and get me their values. And in the case of kiosks, all the listed items are dynamic object fields. So this little snippet says, give me the contents if it's a dynamic object field, which means the listing. And this little snippet says just for each move value that I'm dealing with, so a name and a value, the name and the value in this case, just tell me its type and its content. So let's just run this quickly. So this lock dynamic field is not a listed item, but we can tell that because it's this lock. So we can ignore that for now. But you can see here that I have one kiosk item, which is a bull shark. So that's here you can see in JSON RPC, this would have been your classic 1+n kind of query. So I would have had to fetch all of the IDs of dynamic object fields that this address owned, and then I would have had to fetch the contents of each of those individually. And now you can just, in one request, get all of that. So that's very useful. Now you can see how you can batch up multiple calls into these single requests. And in fact, in the future, we will also find ways to make sure you can run query 1 and 2 here in just one nested request. Now let's look at consistency. So here, I'm just going to do a quick demo, a live demo where I run a transaction. So let's see how this goes. So this query is just telling me, okay, what's the current latest checkpoint and its timestamp? And at this time, what are the Sui coins that this address owns and their contents, which in this case is the balance. So here I have about 13.9 Sui in here at this time. And you can see as I run the query, the time is kind of running up, which is great. But then what happens if I run a transaction? So I'm going to send one Sui somewhere. So I'm going to do that just now using slush, of course. So I just sent that transaction. And now when I run this query, I'm just going to save this checkpoint before I do. When I run this query, we see that the number has gone down. That'll make sense. Obviously, you would expect that the RPC kind of keeps up with what happens on chain. But what if I was paginating through these objects as that transaction happened? It would be confusing if I kind of saw a state of these objects that kind of was smeared over time, just because I requested another page later on, that it now reflects the state of the checkpoint, latest checkpoint when I requested that page, rather than when I first started paginating. So in fact, we actually support a kind of time traveling query here. So even though the latest state shows kind of 12.9, I can run this query that says, okay, at checkpoint, this checkpoint, which was before I ran the transaction, what's the time, and run that same query that I had before. And it should show me my 13.9 again. So that's very useful, right? It means that this feature works for kind of checkpoints in the last hour or so. It means you can give people an accurate snapshot of their state on chain. And this consistency feature, it applies to when you're running multiple queries across a single request. So here, I know that the timestamp I'm being given here, or maybe more appropriately here, the timestamp I'm being given here is for this checkpoint, and this checkpoint is the checkpoint that I'm getting this data from. And it also applies when you explicitly apply this checkpoint like this. And if you were to paginate multiple objects starting at a certain point in time, owned objects, then it would apply it there as well. It also applies for other similar queries. So for example, if I wanted to add a query for my balance of Sui, it will also reflect the same kind of consistent state. So let's run that too. So you can see here, oop, I added the layout. Okay. So you can see here it has the same balance. And if I were to run this in that old previous query, it would show me the new balance. All right, so that's consistency. And then finally here we have another kind of example of batteries included kind of API. So this one is just object versions, a history of an object. I'm able to run a query that tells me, just give me all the past versions of an object. This can be tough because object versions don't just go up by one each time. So this API will allow you to just find all the versions of an object. In this case, the query I'm running says, tell me what the state of the latest version of this object is, and give me the first 50 versions before this object. Now, probably actually what I want to write is the last 50 versions, because I want to go kind of back in time. In this case, there's only about 25 updates, so it doesn't make a difference. But here you can see the balance of it changing over time. And if we were curious about something like at what times was this object being changed, we can write that too. So I can say, give me the previous transaction, give me its effects, and a timestamp there. And so if we run this query, I can see that this object first came about in 2023, and you can see that timestamp going up over time. So that's just a brief demo of GraphQL there. All right, that's everything that we have demo-wise. So thank you for kind of bearing with us as we showed you all this cool stuff. If you are curious about the gRPC schema, that is in that you can find at this link on GitHub. If you want to try out that interface that I was just showing you, that is available at graphql.mainnet.sui.io/graphql. And check out this QR code to view the kind of entry point into our docs for the data stack.
There's a follow-up question to the big table question that's going to be pulled up for you.
I don't think there's a particular license consideration. I mean, so most things that are in the Sui kind of repo, they are all Apache 2 licensed. But Apache 2 is not a copyleft license, so there's no huge obligation on your part. Obviously, we prefer open licenses and for folks to share their code and technologies with the ecosystem. But apart from that, no. Brandon?
Yeah, no, I think that's an accurate answer. Yeah.
Great. Thank you guys so much. I'm going to ask some questions to you, and if anyone in the audience has questions, please feel free to type them in, and we'll try and get to them as well. So my first question for either of you is, how does this new stack reduce complexity or risk for dev teams who previously had to manage their own indexers?
Yeah, I mean, at a first blush, it should mean that in many cases you don't need a custom indexer anymore, which is great. No software is better than some software when you have to maintain a project. Then if you did have to write something, hopefully now that you have this indexing framework, it's that much easier to just focus on the bit that you care about, which is what data do you want and where do you want to store it. So that would be the two main ways to think about it.
I mean, it was we spent quite a lot of time internally to make certain that framework is robust and performant. And there's a lot of edge cases when you're building an indexer that you don't think exist, and they do. And so, yeah, if you can just kind of use that, there's a lot of problems that you can avoid.
Yes, and we also dog food this, right? So the indexer that powers GraphQL that you just saw, that uses the framework. I think we have probably 6 or 7 other indexes that we use internally that are also built on that framework.
Great. I know you mentioned sort of the reasons behind choosing gRPC and GraphQL, but just curious, obviously we had a lot go into this and users and devs testing it, and just curious about sort of the feedback process and how our builders in the ecosystem help shape the development of this data stack.
Yeah, we have a number of different builders in the space. I know there's a bunch of different Telegram channels that exist where these folks can ask questions and provide feedback. And we've spent, if you notice the gRPC API, it's like v2 beta 2 is the package that it's currently in. We've had a couple different iterations on it. There's even the GA schema, the general availability schema that'll be coming out in middle of October. Is even slightly different than the one that I was just kind of showcasing in minor ways, and all of that's based off of feedback that we received from builders. So we've tried really hard to not build in isolation and instead get folks to try things out, tell us what's working, what's not working. I know there's probably going to be more feedback once these things actually get released. And the great thing is that I think we're in a spot now where even if there is feedback that comes back that would necessitate us tweaking or changing things, we're in a good spot to be able to have forward compatibility and add those new features and things like that.
And if you were to tell builders who are watching this and are about to maybe go play with it and start using it, what's the best way to actually offer feedback and share their experience?
There's a couple different places. I mean, leaving GitHub issues is one way that we will see them. I know that, like I said, there are some Telegram channels that people provide feedback in. Ashok, do you have any other places that we've tended to receive feedback in?
Yes, I was going to say we actually have a couple of standing issues on GitHub, which are specifically for the gRPC API and the GraphQL API. So I will find them and we can make sure we show them on screen before we close out today. But that would be a good place to start. But generally, we're listening everywhere. So anywhere that you can reach a developer from ISTM, that feedback should come to us.
So we have a question in the chat of, do we need PostgreSQL in our DApp or app?
So this is, I think, here we're talking about Postgres, because in the diagram there was like a little blob that showed Postgres there. The answer should hopefully be no unless you need to index something that we don't already index in one of these places. So Postgres is kind of an implementation detail of GraphQL, like one of the sources of data that GraphQL uses. But as a dApp developer, the idea is that you just go to an RPC provider like you usually would, and there should be multiple that can serve your needs, and you just talk over GraphQL. And data that is best served from Postgres will be served to you transparently through GraphQL.
So to wrap up, would love to just talk a little bit about this in relationship to end users and sort of what they will experience because of having a better data stack. What are the real world benefits that we might see in a game, in a wallet, in an Explorer, because builders are starting to integrate gRPC and GraphQL?
So the prime one that we did touch on a little bit is better latency guarantees. So one of with the existing JSON RPC implementation, given there's this fallback that mechanism that exists, we've gotten into a situation where some requests return very quickly and some requests time out or take 20 seconds to return. And it's very difficult from an end user's perspective to figure out, like, what did I do wrong? Why did this take so long? And we've tried very hard to architect the system in such a way where, if you're not going to be able to get a response that you'll like the data that you want, you'll get a negative response very, very quickly. And any data that does exist on the full node that you're querying, you'll get it back significantly quicker than you would otherwise. And if you do need that historical data that doesn't exist on that full node, you can go ahead and very quickly go ahead and get it from an archival service. And for those dApp developers that are building front ends that are talking to GraphQL, that's kind of hidden transparently behind the scenes. And the way that this, at least the GraphQL service that we have deployed and are hosting, we've again tried to make latencies very reliable in terms of them being as little as possible.
And to add there quickly, I think hopefully one thing that you should notice is that because developers have to worry about fewer of these things, they ship more. So you get cooler features that are specific to the app, and they don't, those dApp developers don't have to worry about the performance of their data stack. And as an end user, you also maybe have some choice, right, about which data sources, which services you go to get this data, because this should be ubiquitous, right? The gRPC and GraphQL stack is something that multiple RPC providers should run.
And just looking forward, I know that obviously we're leading to general availability, but after that happens, what do you see as the evolution of the data stack over the course of the next 6 months, the next year? And what are you most excited about?
Yeah, so for gRPC, like I mentioned that one of the hottest asks that we've had, the biggest asks we've had, has been for a better subscription service. People really want to be able to subscribe to data, whether that is the checkpoints themselves or particular events that are relevant to your dApp that you're building. One of the areas that we're going to hopefully tackle next once GA happens is fleshing out those subscription services so that you can better filter for the data that you want or subscribe specifically to the particular events that you're interested in. And that'll kind of, again, get us into a world where you reliably know that you missed an event or didn't miss an event.
And on the GraphQL side, after GA, we'll also provide a subscriptions service through GraphQL. So again, if you want to subscribe from an ecosystem where you have good kind of robust GraphQL support, then you can do that. We also are looking into things like making it easier to run just parts of the stack, so that if you want to kind of grow your stack with your needs, every component that you add is only addressing a real need that you have, and you're not running something because you need something else, and it is kind of like tagged on to this thing. So that should really help folks who want to run the stack themselves manage an efficient operation. And then on the indexing framework side, there's some cool work that I'm looking forward to, where we can maybe start incorporating Walrus into the picture a bit more, where Walrus is a great place to store data. So that should also be kind of a natural place where you can fetch checkpoints from and also maybe write data to. So that's something that we're looking at in the longer term.
Great. Well, we've come up against the end of our talk. We want to thank everyone for joining us. Thank Brandon and Ashok for the great presentations and demos and answers to questions. I know there are a few questions we didn't get to, so please feel free to jump into Discord or any of our GitHub, anywhere else that you can find developers and builders, and we'll be happy to answer them there. Looking forward to the next time.